This video is titled, How do you change atoms into ions? First of all, before we start looking at ions, let's just really quickly look at atoms and what we know about them. So here is a sodium atom. Sodium has, you can see the electronic configuration drawn there. You can also see it written. Now sodium, if you look at sodium in the periodic table, you will see that its atomic proton number is 11. Okay, that means that it has 11 protons. Okay. It also means, or we should know, that the atomic proton number is also the same as the number of electrons. So it has 11 electrons. Okay. And this is what I mean here. It says, we say that atoms are neutral. They have the same number of electrons as they do protons. Okay, so atoms, all atoms in the periodic table are neutral. Now, when we start to create an ion, like so, we change the number of electrons, and it means that they will all either have more electrons or less electrons than the number of protons they had. Now, the sodium ion here still has 11 protons. We never look at changing the proton number. You can see, however, though, its electronic configuration has now changed from 2.8.1 to 2.8. It now has one less electron, which can be represented as E minus. Okay, it means that there is more positive protons than there are negative electrons, and you can see here we give it a positive charge. Now, before we draw these ions and represent them in a diagram, we just have to look at a couple of rules. The first one says, if an atom loses an electron, it becomes a positive ion. So the main difference, or the biggest difference between an atom and an ion, not only is the difference in the number of electrons compared to protons, but the fact that they have an assigned charge, and that charge can be positive if it has lost electrons, and negative if it has gained electrons. And I'm going to show you why that charge is assigned, because lots of students get confused and they think, oh, well, if you've added electrons, you must have a plus charge, and that's not the case. So take lithium, for example. Lithium has got 3 electrons in total. Okay, now if you look at the proton number of lithium, you will see that it is 3, the atomic proton number, and the proton number is the same as the number, or the electron number is the same as the number of protons. So we have 3 electrons which are negatively charged, and I can put 3p plus here just to show you that the charge of a proton is positive. So we have 3 positive charges and 3 negative charges. They balance out, and that is why we say that an atom is neutral. Now, when lithium is turned into an ion, it is actually going to lose that outer shell electron, and I'll show you in the coming slides how to draw these, but for the purpose of this slide, the lithium loses its outer shell electron. So to show that it's turned into an ion, we draw square brackets and we give it a positive charge. The reason being is that we now only have 2 electrons, but we still have our 3 protons. The reason being, this electron here has been lost. Okay, so rather than have 3 electrons, we only have 2 electrons. So we have 3 positive charges, 2 negative charges in the atom, so it has an overall positive charge. If you look at fluorine, okay, fluorine is actually going to gain electrons. Look at the outer shell of fluorine. Fluorine has 7 in its outer shell, and its full shell, or the number of electrons that it can hold in its outer shell, is actually 8. So it's going to gain an electron. So here you've got 2 in the first shell, 7 in the outer. We've got 9 electrons here. If you look at the proton number, for fluorine, you will see that it is 9. Now, when we draw the fluorine as an ion, we have 2 in the first shell, and rather than just have the 7 of its own, it actually, and I'm just going to draw it in a different colour, it actually gains an electron. Now, at this point, when you're just forming ions, you do not need to know where that electron has come from, just like how you don't need to know in lithium where that electron has gone. Now with fluorine, it's gained an electron. We draw square brackets to demonstrate that it's an ion. We then assign it a negative charge. The reason being is you now have 10 electrons and 9 protons, and it means that you have one more negative electron than you do positive protons in that ion, so therefore you assign it an overall negative charge. On this slide, I'm going to talk you through a lot slower how we form ions. Okay, now what we need to remember as well is that to be stable, all atoms want to lose and gain electrons. Okay, they want to have full outer shells in order to become quite stable. Okay, now kind of what stability means, it's linked to their reactivity as well, and that comes up in other topics. But in terms of just forming an atom into an ion, you just need to understand that atoms want full outer shells, and they can either gain a full outer shell by losing electrons or by gaining electrons. So take the oxygen atom first of all, 2,6. Now we know that oxygen has 2 shells. Its second shell contains 6 electrons. Now it needs to gain a full outer shell. Now the second shell can hold 8 electrons. So that oxygen can either gain 2 electrons to have a full shell of 8, or technically it could lose 6 electrons in order to have its first shell with just 2 in. What oxygen does is oxygen actually gains 2 electrons. Okay, so the oxygen atom, and I'm going to draw it in a different colour. I'm going to draw the electrons in a different colour. So oxygen will keep its 2, it keeps its 6 that it already had. And what happens is, at this point, you don't need to know where the electrons come from, but the electrons will come in, 2 electrons, and will fill its outer shell. Okay, now to show that that is an ion and not an atom, we draw square brackets around it, representing that it's an ion and not an atom, and we need to assign it a charge. Now, my previous slide, it said that if you gain electrons, you have a negative charge, okay, and then you write a number in front of it based on how many electrons it's lost or gained. Okay, it has gained 2 electrons, so we say that this is a 2- ion. So this is an oxygen ion or an oxide ion, and its configuration drawn will now be 2, 8. And sometimes you see it written in square brackets with a 2-. Okay, now let's look at chlorine. Chlorine has 7 electrons in the outer shell, so its third shell can hold 8 total. Now, rather than lose 7 and its next shell below be full, what it will do is it will simply just gain 1. So chlorine will now look like so. So it has its original 17, 2, 8 and 7. And it's going to gain 1. Again, at this point, you don't need to worry about where that electron has come from. We talk about that more in the ionic bonding video. We draw square brackets to show that it is an ion, and it has a minus charge. Now, I said before that in front of the minus, you can write the number of electrons it's lost or gained. Obviously, this is gaining electrons. You can technically write a 1- there, but lots of the time, you will just see a minus like so. So this is a chlorine ion or a chloride ion, and it's 2.8.8. And like I said, sometimes you see square brackets and a minus charge on the outside. So on the previous slide, we were looking at atoms that were gaining electrons. We're now going to look at some atoms which are going to lose electrons instead. So if you look at calcium, calcium has got 2.8.8.2. So it's only got 2 electrons on its outer shell. So not only are atoms, and I say this to my students in my lessons, not only are atoms wanting to gain a full outer shell, but they're also quite lazy. They want to do it using as least effort as possible. So it's or we can think about it as in it's far easier for that atom to lose 2 electrons than it would be to gain, let's say, 6, 7 or 8 to fill its 4th shell. Remember, we don't have to know at GCSE how many electrons that 4th shell holds, okay? So we're going to lose 2 electrons here. So calcium turning into an ion will look like so. Okay, so rather than calcium now have 2 on the outer shell, as a calcium ion, it now has 2.8.8. Okay, it's actually lost 2 electrons. So we draw the square brackets to show that it's an ion. Okay, I said a couple of slides back that if you lose electrons, you have a positive charge because you've now got more positive protons than you do negative electrons. So you put a plus. Okay, you then write the number in front dependent on how many electrons that it has lost, and it has lost 2 electrons. So we would call the calcium ion a 2+ ion, and again, when we draw the electronic configuration, you can write it like so. Very similar situation for potassium. Potassium has 1 electron on the outer shell. It will lose that 1 electron. And again, just like on the previous slide, you didn't know where those electrons came from. At this point, you don't need to know where these electrons are going. So potassium will look like so. Okay, so this is a potassium ion. Okay, 2.8.8. We draw square brackets to show it's an ion. We put a plus to show that it has more positive protons than negative electrons. Okay, again, we could put a 1 in front of the plus, but we don't have to. And again, down here, we put a plus. Now notice that both the calcium ion and the potassium ion have the same electronic configuration, and that you will see that happen quite commonly. Just to finish this video off, I just want to show you how you actually can represent these ions in an exam. So when I teach this, and you'll see on this video, I've actually included all of the shells in the atoms and in the ions, whereas reality, in exams, you actually only have to show the outer shell. So you could actually show calcium as your finished answer, like so. So just its outer shell only. And you could show potassium like so as well, just its outer shell. The reason I don't teach this, first of all, is because sometimes when you are just showing the outer shell, students are confused about whether it has lost electrons or gained electrons to get that outer shell. Whereas if you draw all of the shells, you can see quite easily. And also if you draw your atom alongside your ion, you can actually see really easily whether it's lost or gained. So you can, in an exam, show them like this with just the outer shell. Of course, I would definitely say do that. I would just say do it when you're a little bit more comfortable with forming atoms into ions. So to start off with, always draw your atom, then draw it into an ion, show all of your shells. Eventually, just draw your ions. You can always, of course, draw an atom at the side of it, but just in terms of what you have to do for an exam, you just have to do what's on the right-hand side here, just showing your outer shells, your square brackets, and your charge.